Good morning, everybody. Today I am going to the subject transforms case study on transforms and partial differential equations for Department of Agriculture and Food Technology students. Uh, Title: A partial differential equation case study on heat equation and pipe expansions. First, we will going to the abstract. In this case study, work presents a discussion and a plan towards the analytical solving of partial differential equation in heat equation using manual solving and symbolic computation. The algorithm is developed in order to make the task of solving easier in the process of calculating exact solution for partial differential equation. Next, going to the introduction. A partial differential equation PDE is a differential equation in which the unknown function depends on two or more independent variables. For example, ux minus 3uy equal to order of 1, 0 equal to 0. This is an example of a typical partial differential equation in which u is the unknown dependent variable with x and y are the independent variables. The definition of order and linearity are exactly the same as in the ordinary differential equation case, with the provision that we classify a PDE as quasi-linear if the highest order derivatives are linear, but not all lower derivatives are linear. Thus, equation is first order linear PDE. It is a second quasi-linear PDE also given. The partial differential equation have many applications and some are designated as classical, much like their ODE counterparts. Method of solving the partial differential equations. Thus, the various methods used to the solving partial differential equations they are: first one, separation of variables. In mathematics, separation of variables, also known as the Fourier method, is any of several methods for solving ordinary and partial differential equations in which algebra allows one to rewrite an equation so that each of two variables occurs on a different side of the equation. The method of separation of variables is also used to solve a wide range of linear partial differential equations with boundary and initial conditions, such as heat equation, wave equation, Laplace equation, and Helmholtz equation. There are numerous useful integral transforms. Each is specified by the choice of the function k of two variables, the kernel function of nucleus of the transform. Next, going to the impulse responsive functions. In signal processing, the impulse response or impulse response function of dynamic system is its output when presented with a brief input signal called an impulse. More generally, more generally, an impulse response refers to the reaction of any dynamic system in response to some external change. In both cases, the impulse response describes the reaction of the system as a function of time, or possibly as a function of some other independent variable that parameterizes the dynamic behavior of the system. The integral transforms the mathematics any transform t of the functions, the input of the transforms of the function f and the output of the another function of tf. An integral transform is particular kind of mathematical operator. There are numerous useful integral transforms. Each is specified by the choice of the function k of two variables, the kernel function or nu cs of the transform. In these functions are represented by their values in the certain grid points and the derivatives are approximated through difference in these values. Next, it often happens to the solution of u of a boundary value problem for a PDE. The region are also minimizes a certain integral in this PDE Laplace equations. Next, method of solution. For this work, we have decided to focus on particular method which is separation of variables. This method assumes that it is possible to separate the combination of the independent variables into separate function that each involves only one independent variable. Separation of variables is the method of solving ODEs or PDEs whereby an equation of two variables is separated into a product of two equations. The more effort should be put in the development of algorithms for solving partial differential equation. Frequent and continuous use of computers in the analysis and study of partial differential equation should be highly encouraged. This can be split up the independent ordinary differential process. This idea separation of variables is quite simple. When a problem such as our problem u of x comma t is posed, one can look for product solutions in the form of u of x comma t equal to x of x and t of t. These solutions can be done by inserting x of x t of t into the partial differential equation for the variable u and then separating the variables so that each side of the equation depends on only one variable. Once the equation has been broken up into separate equations of one variable, the problem can be solved like a normal ordinary differential equations. Computational partial differential equation should be taught as a core course in universities. Existing algorithm and source code for solving partial differential equation should be modernized and extended. Is this problem in this problem we have to conclude that the simple example the functions apply the method of separation of variable in given differential equation for f u of t comma x, assume that the solutions has to form the a of t and b of x. Also divide the both sides of resulting equation a of t b of x under the rearrange so that all the a's are on one side and all the b's are on one sides. Going to separate and the split up, we get the answer in correct equations. We taught the heat equations also. The partial differential equations is widely useful to all the problems also. Next, we going to the conclusion. The conclusion drawn from my findings are as follows. The partial differential equation in heat equation can be solved analytically with the aid of computers. With computers, the solving of partial differential equation, heat equations, is far less tedious as opposed to carrying out manual computation. This work is an instance of this. Computer program used in solving problem in partial differential equation. Computer problem is Computer problem used in solving problem in partial differential equation or heat equation gives an easy approach towards actualizing and visualizing the results. Thank you. Thank you for watching my case study.